In 2008, Heartland payment system experienced a significant data breach. The incident involved the exploitation of an SQL injection vulnerability by attackers, who were able to gain unauthorized access to the company's payment processing system. As a result, the attackers were able to steal millions of credit card numbers, which had a severe impact on the company's reputation and financial stability. The breach not only resulted in significant financial loss for Heartland and its customers, but also served as a wake-up call for other organizations to take data security more seriously. And that's why in this video, we will talk about SQL injection. So what exactly it is? SQL injection is a type of attack where an attacker injects malicious SQL code into a vulnerable application database query. Okay, let's take a look at this example, then it will make more sense. Assume that there's a search bar on an e-commerce website that allows users to input a keyword. The server then displays products based on the search keyword. The server is using SQL as its database for storing information about the products. Over here, you can see the green text. This is the SQL query that fetches products from the database. If the keyword exists, the condition will be true and the product will be fetched. If the product does not exist, the condition will be false and no product will be fetched. Note that whatever keyword the user inputs in the search bar, it will be enclosed in quotes in the query. Now, let's understand what this query does exactly. The query selects star from products where a name like keyboard fetches all columns from the table products where the name column matches the string keyboard using the like operator. The like operator is used to search for a specified pattern in a column. In this case, the pattern being searched for is the string keyboard. So if there is any column that matches the word keyboard, it will be fetched and displayed on the screen. Otherwise, it won't. Okay, so this is how this query is normally working. How an attacker can exploit this. To exploit it, first an attacker needs to know if the database being used is SQL or not. To determine if a system is vulnerable to SQL injection, send a request to the server with a single quote. If an error is generated, then it is very likely that the system is indeed vulnerable to SQL injection. Why we are using single quote, you must be thinking. Well, SQL uses single quotes as string literals. And when you send code to the server, it will generate an error. Because the single quote interferes with the SQL syntax and breaks the query. The resulting error message can reveal important information about the structure of the query, database, or underlying system, just like this one you can see on the screen. So the error will look something like that. It can be different according to the technologies that is being used. Okay, now that we have confirmed that the database is indeed vulnerable to SQL injection, let's move on to the second step by injecting a malicious SQL query. So this is the SQL payload that we are using, quote r1 equals 1 dash dash. This can be used to exploit SQL injection vulnerabilities. How so? Well, it works by appending a condition to an SQL query that is always true, 1 equals 1. 1 is not equals to 2 or 3, 1 is indeed equals to 1, and hence it's a true condition, which makes the query return all the rows in the table. Okay, remember when I said that if the product exists, then the condition will be true and it will be fetched and displayed on the screen. Otherwise, it won't because the condition is false. Just like that, we have appended a new query here, and this query will always return a true condition no matter how. The double dash at the end is used to comment out the rest of the SQL query, which prevents error from being thrown. This payload can be used to bypass authentication mechanisms and gain unauthorized access to data. In this case, we are trying to fetch all the products, even those who are not supposed to be listed on the site. So now that you have basic knowledge about the SQL injection, let's move on to the practical demonstration where we will see how you can exploit SQL injection in an API endpoint. So I have imported an API collection in Postman. This endpoint allows the users to log in, after which the server provides an authentication token. This token must be included in all the subsequent requests sent by the client. There is another endpoint that allows users to fetch their own information like username and email. There we can also see the path variable, that is :username. and its value is name1, which is basically a username, so it identifies which user details to fetch according to the username in the path. To test for SQL injection, we need to determine whether the server is using SQL. To do this, we will inject a single quote into the username value and send the request. And there we can see a SQLite operational error. And we can also see the SQL query select star from users where username equals name1, and in the end we can see double quotes. And that's what causing error, because it's a wrong syntax. Now if I remove the single quote and send the request again, there is no error. Okay, so now that we have confirmed that the server is using SQL, we can try to exploit it. This time I'm going to use a tool that will automate the testing of SQL injection, that is SQLMap. So the command goes SQLMap --URL and put the URL in quotes. Keep the level to 3 and risk to 3. This will basically do a more aggressive testing. Now hit enter. It will ask if you want to try injection in the target URL itself. Type yes. In the result, we can see that the backend database is indeed SQLite. And we also confirm that in the error. I'm going to type the same command again, but this time I'll add an option to dump all the table entries from the SQLite database. With this command, we get the entries of two tables, username and books. Users table is particularly interesting because it contains the email address, passwords, and username of all the available users. And also we can see that which user has admin privileges and which does not. In the book table, we can see the book title, user ID, and the secret content that they have. This was all possible simply because the user input was not being sanitized and validated properly. Another thing you can do is implement a firewall that doesn't allow suspicious inputs such as codes. And if you're using external software or frameworks, make sure to keep them up to date with latest patches. Okay, that's all for today. I hope you learned something from this video. Don't forget to like and subscribe, and I'll see you in the next one.